Hi guys, this is Tommy from Volvo B230 Racing. This is episode 2 of the 600 horsepower Redblock build. In this episode we are going to prepare the block and the rotating parts to be assembled again. We are going to start with cleaning the block. We are going to re-deck or deck the block, deglaze the cylinders. The beginning in the video now we are going to clean the block in the hot water cleaner. I also want to say thank you to all you guys that's liking and subscribing to the channel. It's mean a lot for me. It's very fun to see that there's so many people around the world that's looking at these Volvo engines and at my channel. If you're new to the channel and you've never seen what I've done before, I'm a cylinder head builder and porting guy, and I have engine dyno and chassis dyno and some. I got pretty much all you need to build an engine here in my shop, so I'm doing all kinds of that stuff. So if you are interested in engines, machining, flow benches, crazy stuff like home build things, this is the channel for you. The engine block is cleaned and we have put it up in an email. We are going to deck the engine block because this has O-ring grooves that are a little bit too narrow. I want the grooves to be a little wider out so they hit the gasket a little better. So I'm planning to mill the block about 0.8 millimeters. The groove is around 0.8 millimeters, and I'm going to make a new groove that's a little bit farther out. So I'm going to mill it now, and then we are going to make some new grooves here. After that, it's time to hone the cylinders, to deglaze it, and yeah, I think it's about to be painted after that. Now the block is decked and it got clean at 0.835 millimeters and all the O-ring grooves are gone. After the decking, it's really important to make a little chamfer here. The blocks are getting razor blade sharps in this area here, and it's going to be a little bit easier to install the pistons with all the rings if you break this edge. After the work here in the mill, we have to compensate the deck height in the on the pistons, because the pistons now will sit 0.8 millimeters above the surface of the block, and I'm planning to do a custom thing on the pistons, because I want to have the quench area as small as possible, because on a turbo engine you can't run a tight quench area. Here I'm making the O-ring grooves, and this is an home built tool. As you can see, I have chamfer all the main studs bolts, because we don't want any cracks or problems around this area. Here the preparation for this cylinder block is coming along good. O-ring grooves are done and finished. Next up is deglazing of the cylinders. I'm going to turn the light on. I don't know if you can see, but it's pretty shiny, the cylinders in this. Maybe here. It's like a mirror finish. So we are going to deglaze the cylinders next up. Okay, let's talk about some honing equipment. This one is a micrometer set honing. This is making round holes, and it's fairly cheap on eBay. It's a Lysol 15,000. Worked. I'm kind of happy with this. It's a cheap thing, Chinese product, and I'm asking for a better result, so I bought a used Sunnen AN hone. This is the stuff that the big boys using. Waiting for some new stones to this. I have stones ready here to the work on my engine block, and this is probably the one I'm going to use. I'm fairly new to this, so I have to study this part of the honing a little bit more before I'm getting to the honing. In the most case, you are familiar with this one, a 3-stoned part on. It's a springy one, and this is a 280 grit stone that's made for deglazing the cylinders. It's not a honing thing. This is not anything you're using to hone the cylinders. I'm waiting for more stones to this Sunnen honing head, and probably going to use this in the block. I'm going to try it out. Okay, I'm going to finish off the block in honing. I've done all the cylinders, so they are in perfect round condition. I'm going to show you a little honing sequence here. A few steps later, and I'm finished off the honing of the block, and there was a 280 grit session and plateau honing session at the last step. If you don't have these tools like I have with a micrometer adjustable honing head, I suggest that you get in touch with someone who got this equipment, or if you want to use that free-armed spring tensioned honing stones that you can buy almost everywhere. You can also deglaze it with that, and you have to be aware of that you need to do the crosshatch movement like I did in this video. Here you're gonna see me cleaning up the block before painting, and I'm using simple tools here, just some wire brush and my drill. And I'm coming back to you when it's time to mask the block. One neat thing is to use a regular file and just file over the edge instead of taking a knife and cutting the edge. This is a much faster way and it's going to be a perfect seam. This is an easy way to make good corners and good shapes, and it's pretty fast, and it will do a very good job on an engine block. Here we have perfect outer line of the top deck, and I'm going to do so at all the edges that really matters. So it's not much more to it. All the edges that shouldn't get paint on is masked. In the front of the engine I got some old covers and an old water pump that I will use to cover this area off. As you see, the water pump and the cover in the front of the engine has been acting like masking before. It's a good way to get the good end result. Okay, we have to talk about the pistons in the engine right now. This is the pistons that sat in this engine before I take it apart. This got a C-stamped piston. That kind of piston is too small for the engine block that I own right now, and I have an idea what I'm going to do when the honey is bigger than the pistons allow. Here we have a piston that I made right now, and this is an E-stamped piston. As you can see, this is a machined piston. I took off 0.6 millimeters of material on the top of the pistons. And if you remember, I decked the block 0.8 millimeters, and my intention is that I'm letting the pistons go above the deck surface of the block with 0.2 millimeters. That's because I want to try to raise the compression in this engine right now, and I want to try it with a fairly amount of tighter squish area. But squish and turbo engines is not a hand-in-hand situation often you see engine builders removing squish area and quench area, and often they make a bigger tolerance between piston and cylinder head, so the quench area is almost gone, and it is gone in many of these turbo engines. But I'm going to try out a little tighter squish, and the problem with that is when you get a lot of boost and a lot of fuel in the cylinders, you don't want the fuel to accumulate in the squish areas, because you can't compress fluids, and if you compress fluids you will crack the bearings and probably some more things. So in this case I don't know if I can show this for you here or not. Maybe if I do it like this. On top of the piston there are a slight gap in the light into the center of the pistons from the squish area at the far out edge. That's because I leaned this quench area into the centrum 3 degrees. So when this piston hits the quench area, it will force the gases to the center of the combustion chamber. So I want to try this in the engine, and as you see, this old turbo pistons has a much bigger dome, and this is going to be a more compression to the engine. I want to try to run the engine at 9.5 to around 10 in compression ratio, because we're running on E85, and you can almost do whatever you want to this engine if you run it with E85. But how much bigger is an E piston between an C stamped piston? Here we have some parts that I will wash off and clean, and I don't know how much work I will do to this, but since the block is newly painted and look really good, it will be a shame if I let these parts be dirty and old and shitty, so I have to do some overhaul on these things. So I'm planning to take this to the ultrasonic cleaner, and maybe I have to paint something of this too to make it a nice looking engine. In the ultrasonic cleaner I have a water and degreaser only, and let the sound waves do the job. This is a very good solution to keep engine parts cleaned, and it's very effective, and you don't have to do it by yourself. The machine is running all by itself. And here you can see me handling all the cleaning of the oil channels on the block as well. I'm degreasing and spraying a lot of brake clean and finish off the last debris that's left in the channels here. I'm taking out all of the plugs in the channels that are in the front of the block and in the rear of the block. Totally there are 3 plugs that plugging off the oil channels. After a lot of cleaning in the engine, there are time to mount the plugs again. In the front of the engine there are 1 plug mounted, and you can see here in the rear there are 2 plugs mounted. Very important to remount them again. Here you can see me cleaning the threads for the head bolts. This is regular M12 bolts. And why am I doing this now? Because you is supposed to do this before you hone the engine, because you need to hone the engine with a torque plate on it. And I didn't have any torque plate when I was honing this engine, so I know there will be a fairly bad job on this, but I think when Volvo did this, they also didn't have any torque plate on the engine. And I will try to run it like this, and if it's a problem I will just redone this work and do it with a torque plate. And this is why you should get somebody to do this work for you, so you don't screw up this honing process. Here we have all the parts, at least the most of the parts that we are going to use for the reassembly. In this video we have made a new block and honed an original block for original pistons and painted it. We have checked the balance of the crankshaft and the rotating assembly. One thing that's left to check is balancing the rods and the pistons. They used to be in a good order. In the assemble part we are also going to install the O-ring, the stainless steel wire. We are going to put them in the grooves in the block. And I don't know what this shaft is calling, but it is this thing drives the oil pump through a little gear here, and that's all the thing that's doing right now. In the carburetor engines, this knock here is a grinded cam, so it drives the mechanical fuel pump. We're going to reuse the main bearings. It was new bearings in this. All the bolts and nuts, you're going to reuse them again. They are washed in the ultrasonic washer cleaner. And we got L-ring, head gasket, and the rest of the bottom end is L-ring gaskets. Maybe I grind this mechanical fuel pump cam knock here to be like a homing sensor knock. You can, on this engine you can use this port when the mechanical fuel pump sitting. If you grind that knock sitting in here, you can use that as an home position if you want to run the engine sequential. So I think I'm going to do that if I want to run the engine sequential in the future. That's all for this episode. In the next episode we will assemble all the things, and probably, I don't know, but maybe we are mounting it in the car and assemble the head in the car. I think I will do it in that order. And if you like this, subscribe, like the video, and stay tuned for the next episode. Thank you for watching.